to 2.3 intro, take 15.
Hi guys, welcome back. I'm Matt and this is Xavier. I'll be demonstrating and Xavier's going to be narrating. We're looking at experiment 2.2, purification of tris ethylenediamine cobalt 3 chloride by column chromatography. And later,
we're going to be analysing our fractions by UV-Vis, so stay tuned for that. It's going to be a good one. Enjoy. So just running the water into the beaker slowly drop by drop and waiting for the meniscus to hit the top of the Cephidex. And once we're there, that'll close the stopcock and stop the flow. Alright, so now that we've run all the excess water out of the column, Matt's going to load up our sample mixture. So doing that very carefully with a pipette, dropping it slowly onto the top of the column so that we don't disturb the Cephidex at the top. So once he's loaded up about a centimetre of the sample, we'll open the stopcock again at the bottom of the column and run the sample into the column. Alright, so we've run the column for a couple minutes and let the sample run into the top of the column. The meniscus is just sitting above the Cephidex now. So Matt's going to load in carefully about a milliliter of deionized water. Again, he's doing it very slowly so he doesn't disturb the top of the column too much. Once that's loaded in, we'll open the stopcock at the bottom of the column and let it run, and the DI water should push our sample into the Cephidex. Alright, so we've repeated that process twice with the deionized water, and you can see that that's pushed our sample nicely into the top of the Cephidex. So now we're going to repeat that process with 0.5 molar sodium chloride. Again, adding it very gently to the top of the column so we don't disturb the Cephidex. And we'll open the stopcock to run that through, and the sodium chloride should start our separation process. Alright, so we've repeated the addition of sodium chloride 0.5 molar twice, and now we're going to fill up the top of the column with 0.5 mil sodium chloride, starting slowly and carefully so we don't disturb the top of the column too much. And as you build up a little bit of volume, you can add the sodium chloride faster and faster. You can see that even the couple of mils of sodium chloride that we've run through the column already, we're starting to get a little bit of separation. And as we run through more 0.5 molar sodium chloride, we should observe some definite colour separation from our sample. Alright, so the column's been running for about half an hour now, and we can see that we're starting to get good separation, and we've got two distinct colour bands. The top one's like a pinky purple and the bottom one's yellow orange, and we'll continue to elute that using 0.5 mil sodium chloride and collect the orange fraction, a transition fraction, and also a pink purple fraction. Alright, so now Matt's going to make up our solution to run a UV-Vis spectra. First he tears the weight of the beaker. Once that's stabilized, it's going to weigh out about 50 milligrams of our compound. Now this measurement doesn't have to be spot on, but you do have to record exactly how much you weigh out, because we'll have to work out a concentration of our solution that we make up. So we'll just shut the doors on the balance, let that stabilize, and we'll record that mass. And then we'll move on to the standard solution step. Alright, so we're making up our standard solution, and a couple of things that are critical when we're doing this is we want to know exactly how much of the compounds is in the solution and also the exact amount of solvent, in this case water. So it's a little bit difficult to transfer dry solvent into the volumetric flask, so what Matt's going to do is dissolve up his compound that he's weighed out accurately in a bit of deionized water, and then he's going to transfer that into the volumetric flask. So we're aiming for a total volume of 25 mils. So add in about 10 mils of water. Check that the sample is fully dissolved. And transfer that carefully into the volumetric flask. So the important thing here is to not lose any of your sample, because that's going to change the concentration. So once he's transferred that into the volumetric flask, use a little bit more deionized water in the initial beaker where he weighed out his compound. And that'll just rinse the last of the sample into the volumetric flask, so that way we know we haven't lost any. Just transferring it slowly and carefully into the volumetric flask. The total volume we're aiming for is 25 mils, so he's probably sitting around about 18 to 20 at the moment. You don't want to overshoot the 25 mil mark. We'll rinse the last of the compound off the beaker walls into the volumetric flask. Now at this stage, he's going to add water using a pipette, dropwise into the volumetric flask. This way he's got a lot more control over how much he's adding, and he can make sure that he's accurately made up the volume so that the bottom of the meniscus is sitting at the mark. Alright, so now Matt's made up the volumetric flask so the meniscus is just sitting at the mark, the bottom of the meniscus on the mark, which means we have a known concentration for our UV-Vis spectrum. Alright, so in the next part of the prac, we're going to record the UV-Vis spectrum of our sample that we made up in our volumetric flask. So the first step is to record a baseline measurement using just solvent, in this case deionized water. So Matt's going to rinse our cuvette out a few times with DI water. Make sure it's nice and clean. Fill it up, cap it, and it's going to rub down the sides of the cuvette. And notice on these cuvettes there's two sides that are clear and two sides that are frosted. You want to keep the clear sides nice and clean, and when you pop it in the spectrophotometer, you want the clear sides to be in line with the path lengths, in our case left to right. Close up the hutch, go over to our software, and we're just going to read the blank. Alright, so now that we've zeroed the instrument, we're going to run a baseline spectrum just with our deionized water in there. So we're collecting from 300 to 800 nanometers. this baseline spectrum will give us a correction factor for our solvent, in this case deionized water. Okay, so now that we've recorded the baseline spectrum with our solvent, in this case deionized water, Matt's going to remove the cuvette, tip out our solvent. He's going to load up our sample. First step is rinsing out the cuvette with a little bit of sample. And this just makes sure that there's no solvent lying around in the cuvette which will affect our concentration. So I'll rinse it a couple times, including the cap, with our sample solution. And once we're happy that the cuvette's been thoroughly rinsed out with sample solution, we can load up our sample. Cap the cuvette, and once again clean down the sides, paying special attention to the clear sides. And we'll load it up, once again making sure the clear sides line up with the path. Once our sample's in, we'll hit go. Alright, so once our sample's in position, we'll hit start on the software, name our file, and begin collection. Again, we're collecting it from 300 to 800 nanometers. And we're starting to see a response around about the 500 nanometer mark. Now we have our spectrum.